learning about in science and the reason why we decided to do a STEM challenge on levees? Tell me. Okay, we were talking about control processes. What else were we discussing, Joshua? Destructive and constructive processes. Who can remind me what a destructive process is? Destructive, Zoe.
Destructive process is a process that breaks down.
Good, that breaks down the earth, okay, or the earth's surface. What is constructive? Constructive, Mariah.
Constructive processes are processes that build up Earth's surface.
Good, build up the earth's surface. And we also talked about some examples of destructive and constructive processes. So we're going to continue with our STEM challenge today. And so let's look at the standards that we are going to cover. We are covering multiple standards through this lesson. Our first standard that we're covering, which is actually our science standard. And this is one of the standards that we just talked about. So our science standard that we're covering is S5E1. Could anybody tell me again what was S5E1? What does that stand for again? S5E1, Ivan.
Science, Earth,
Science.
Science, 5th grade.
5th grade, good. E stands for?
Earth.
Earth, science, good. And what's that one? What's that one? Standard 1, good. Standard 1, that's the first standard up under Earth science. But now look, we have a letter C. So that means that this is element C. This is the C. Okay, it says relate the role of technology and human intervention in the control of constructive and destructive processes. And we're going to focus on flood control, such as dams, levees, storm drain management systems, etc. We've already done the levee, so we're going to actually focus on the dams today, okay? We are also going to focus on a math standard because we're doing some converting units, okay? So let's look at the math standard. Our math standard that we're focusing on, all right, is MGS E5.MD.1. Who can tell me what does that standard mean? Amanda.
Math, Georgia.
We're going to get you some help. It's okay. Math, Georgia standards represent. If you don't know, you can get somebody to help you too. Ethan?
Measurement and data.
Good, measurement and data. And then, of course, the one is that means that this is standard 1. So we're focusing on this as well. And then there's one more standard that we're going to look at. And you might say, wow, how does this standard actually go along with this? But I'm going to explain that to you. This standard we talked about before. This is a social studies standard. SS5H5, which we know stands for Social Studies 5. And this is our history standards, right? Listen to this standard. The student will explain how the Great Depression and New Deal affected the lives of millions of Americans. And you're probably, oh my gosh, what have to do with what we're getting ready to do? How does this social studies standard about the Great Depression and New Deal tie into our STEM challenge for today? How do you think that ties in, Kaden?
Cause like the TVA, they made like dams and levees. And that was part of the New Deal.
Excellent. So what was the TVA again? He said the TVA made dams and levees. Okay, so what was the TVA again? Xavier.
It was the Tennessee Valley Authority.
Excellent, the Tennessee Valley Authority. And so the reason why this has something to do with our standard is because this is something we've talked about before. And I'm actually getting ready to show you a quick video. But our essential question today, you guys, that we need to be able to answer is, what are the multiple ways that dams can be beneficial to our environment? All right, so let's look at this video. Look at all that incredible information, too, about the Hoover Dam. John. design process, the engineering design process, is that you were supposed to imagine and brainstorm. You were supposed to come up with a design. So everybody should have had an opportunity to come up with a design. I want you to take the designs that you guys came up with out. Take those designs out. So we've already done part 2. So we're going to really move on to part 3. Who can tell me what part 3 is? What is part 3, Xavier?
We need to share our ideas with our group.
We're going to share our ideas together. So we're going to plan and design together as a group. So I'm going to give you time now as a group to go ahead and share out your designs. And then you're going to choose one design that is going to represent your group's ideas. Are we all listening?
One of them has to do it that easily. And then I was thinking we should put 2 sponges right here, and then pack the sand so the water, so it can keep the sponges together, and also keep the water from flowing through the crevice in the sponge. Oh, this is a door to the water inside, but it's gonna be like lower a little bit so to let the water inside. And I was thinking we could use sand because like gravel didn't work last time, so I was thinking we could use sand. So because it would be harder for the water to pass through.
Instead of and then I put sand over here. Because this is where the water is coming, and then the water rushes and it goes under, and then right here you can stop it, and then
Are those sponges?
Look, I put cardboard to seal cardboard, and then this is sand. Sand and gravel, because both of them, if you add it with water, it can actually make a texture, and then it will sort of be harder. And then, yeah, that's all. And then, oh wait, no. Here, I have cotton over here.
The cotton ball is for?
So it can teeter.
Oh, okay, teeter. Okay, so it's sort of adding a balance to it. Okay. All right. Did anybody else have any ideas? Okay. So where's your idea, Amar? We are down to maybe about 3 minutes left to share your ideas with your group.
So are we merging?
What's the final design?
I know, I get it. We're deciding if we're merging. I like the design with the trap. Okay, so we need to find out how we're gonna merge the designs. Okay, so what are we gonna use? Yeah, sand. So 2 cups. No, we should do 2 cups of sand and then 1 cup of gravel.
When you just came
We should add sand so that the stair
it doesn't lean
What do you use
the
to
wall.
reduce the flow?
Okay, we can. What do you think?
I actually like that idea, except wouldn't it like so how would we stop we should add a bit.
But what are you using? What materials do you guys think you can use for that? What could you use? Okay.
If you can use the clothes, I want to put like if you put clothes over here, and then it's like kind of like water content.
Final cost.
This will go over slow. We really need to listen to
So wait, so how much?
Are you all ready to shop? Okay, so let's see what you have. Let me see your math.
We need 2 cups of sand.
We could do this.
So can I go ahead and
Okay, you're getting 2 cups of sand. How much is that?
that's $2,400.
That's how much?
2,400.
Okay, and what else?
We need 4.
You need
We
what?
need 4 sets of cotton balls.
4 sets of cotton balls. How many cotton balls come in one set?
5.
So you need a total of how many cotton balls? Okay, so one of you guys can count out. Now I do have to ask, is this your original design?
Yes.
With those cups in there? No, it's not part of your original design. No, let's stick with the original design, Joshua, and test that.
Let's change our.
Stick with the original design, and then you can test the original design.
I bet you these cups would be like if we put them at the top, it could automatically catch the water. Yeah. Well, we don't need to catch the water. Yeah. This is actually. We could turn the cups like if we can improve our design. We improve our design. We can't put it over here. So I think. So we need to add more.
The fact that there's a hole in the water is too hot.
I'm saying like.
Now this idea is totally confusing.
Is this your original? Is this your original design?
Yes.
Okay, so this is definitely the original design. Can you explain to me what's going on here?
Okay.
Okay, so
Okay, so it's not working. It's not working the way I was hoping it would be planned. But what we were trying to do was we were making a little hole. So if the water gets too high, then the cup could kind of block it, and no one would be able to.
And that's not gonna work because it's gonna because you're what's gonna hold this. I thought that this was gonna hold this. Oh, that could force me to hold both of them. Exactly. Then we'll use that one. Yeah.
Is that your original design?
No, but we combined design.
Okay, so remember step 3, you guys had to come up with a team design. So it should mimic, your prototype should be what your design is. So you don't know if it's going to work or if it's not going to work because we haven't gotten to the stage where you test it. So let's go back to your original design that you guys came up with as a team, and let's create that prototype and test it.
Remember we said that
Has some criteria. So let's go back and review our criteria as we get ready to test this group's dam. What was one of the criteria? What was one of the things that it had to be able to do? Does anybody remember? Catherine, what was one of the things it had to be able to do?
it has to be able to like last. Well, it has to be able to be. There can be at least 2 liters of water poured in.
Okay, a minimum of 2 liters of water should be able to be poured in. But it was something else that was very important that it had to be able to do. Ethan.
You need to be able to let water go through, then stop the water, then let it go through.
Does anybody remember? So we had Catherine, what was one of the things it had to be able to do?
It has to be able to like last. Well, it has to be able to be. There can be at least 2 liters of water poured in.
Okay, a minimum of 2 liters of water should be able to be poured in. But it was something else that was very important that it had to be able to do. Ethan.
You need to be able to let water go through, then stop the water, then let it go through again.
Excellent. So we had to be able to allow water to go through. So it had, first of all, it had to be able to just stop the water from flowing. And then you had to have some type of mechanism to allow the water to go through and then stop it and the water could not. Okay, stop. Is there any water going through on the other side? Okay, so let me see the other side. What you guys created to be a release mechanism that would allow the water to flow out, and then you could stop it again from flowing.
So when we wanted to get water onto the other side of the paperboard, or which is our dam,
we would lower the straws, so hopefully the water would be sucked up and poured into the other side.
Okay, so the straws are going to suck the water in used as a suction device, and then you're hoping that the water would pass through the straws and end up where?
End up into this part.
Okay, what does that part represent?
That part would represent a river.
Okay, the other
Share
side of
out
the river.
how
right?
we would have improved our designs to make
Joshua,
them.
how could you improve the design that your group had?
Well, I thought instead of just having one wall, we could have two. So, and then we could have a straw going from one wall to the other wall. And then behind that wall, there's a smaller wall that has a popsicle stick. Wait, but on the first wall, it has a trap door so you can open it and close it. And then on the second wall, it has a popsicle stick that's blocking the straw from letting the water out, and you'd have to pull it to let the water out, and then it goes through a straw.
Think that
Okay,
your group's
so
dam could have been improved.
Well, what my sketch was, well, I was thinking that maybe the things that we already had are the same things that I have on my design, but it's basically like two walls together, and then but not together, and in the middle it has a sponge so that if the water goes in, it can collapse in there. And if this was sort of like a real world problem like that, and people needed water, there's sort of an opening right here so that if any needed water, you can take it.
Okay. All right, that's a good. Maybe if we made our dam convex or concave, could that have possibly made a difference in the way the water flowed? Possibly. Okay. Of course, the thickness of the dam, that's something else that could have possibly made a difference with the way that the water flowed. Okay. I think overall you guys did an awesome job working as a team, collaborating with each other and sharing your ideas, and there was definitely a lot of critical thinking going on, and I certainly appreciate that. Okay, the last thing that we are going to do, and this is something that you definitely will do independently, there is a survey that I am going to have you guys answer, and you'll share your experiences